Right, what I'm going to do is just to give you a brief illustration of the USDP. We've been talking about the USDP for the last few weeks, so what I'm going to do is take the case study that you've been working on in the tutorials, take a small part of that and then talk you through the process of the requirements workflow into the analysis workflow and then the design workflow, and illustrate that with these diagrams that are prepared already. These are all up on Blackboard, so you can go back and have a look at them in your own time. Okay, what I've used for the use case model is Microsoft Visio, and it's not too bad. You can save the file as a PDF, which makes it very useful for submission. And one or two little oddities, for example, whereas we've been talking about includes, you haven't got an includes annotation. You have to use uses instead. It's the same concept. Let's start off by reviewing the garage problem outline. So a garage can have a number of franchises and so on and so forth. The garage employs a number of sales personnel, and the sales team is very successful, but it's increasingly difficult to manage the paperwork. And so we need a computerized system to take care of all of this lot. Now, for the purposes of this little discussion, this illustration, what I'm going to focus on is this one area, which is planning employee shifts. And so what we need to do is to think about that problem area. In the real world, of course, you'd go and talk with the clients and you'd think about this area with them, you'd discuss it with them, find out what they're doing, find out what they want the system to do. And as you do that, you will come up with a use case model. In the use case model, we do not describe a data flow diagram. Okay, a use case model is not a data flow diagram. So whatever we learned last term, you forget entirely, because it's nothing at all to do with a use case model. Instead, what you really ought to be focusing on is finishing this sentence. The user wants to use the system to ... and you fill in the ... So for example, here we have the manager wants to use the system to plan a shift, wants to use the system to modify a shift, wants to use the system to view shift details, wants to use the system to view all shifts. And the salesperson wants to use the system to start a shift and to end a shift and to view my shifts. So what we're focusing on here is a very high level of abstraction. No detail at all. It's simply a statement of, I want to use the system to, and then in 2 or 3 words describe what that requirement is. Now, of course, we'll put in detail as we go on, but at this stage all we want to do is to capture that very high level of abstraction. The solid lines just indicate an association, so it shows that the manager is going to perform these functional tasks and the salesperson is going to do the other 3 tasks. Sometimes, as we saw in the lectures, you might have more than one actor engaging in a particular use case. The uses annotation here, this dotted line, which in the lectures we noted was had a stereotype of includes, simply indicates that when the manager wants to modify the shift, the manager will want also to use view shift details. So in my mind, when I was planning this, the user would start off by viewing the shift details and selecting the required shift and going in then to modify that shift. But the point is that these use cases are independent. One does not rely upon the other, and they are complete flows of activity. So, as we shall see in a bit, there will be a start and an end to the view shift details. And then from there, if we choose to, we can go on then and start another activity, which is modify shift. What we've got then is a use case diagram like this. Now obviously we're only focusing on a very small part of the system, but I didn't want to flood you with lots and lots of use cases, because what I'm illustrating here is the process that you would go through. And it's a process that I recommend for your assignment. Now, I've seen some of you start off with class diagrams, which before using the USDP would have been what I did. Start off with the class diagrams, leap straight into the design, and it's a really difficult process to do, because you have to keep fiddling with this and fiddling with that and refining this and refining that, and it becomes really quite difficult. What I was very pleasantly surprised about when I first used the USDP was that this flow, which is, don't forget, use case driven, becomes a very easy way of getting to the design. On the next page, we start to plan the activities for each of the use cases. So for example, the plan shift use case will have its own activity diagram. The modify shift will have its own activity diagram. And so when we come into here, I've put on here 4 activity diagrams on the one page, and you can see that some of them are not terribly adventurous. There's not much to do. For example, view shift details. This is the initial point that we start at in the first node. We follow the arrow and we display shift details. That's all we need to do. That's the only activity, and so we then come to the final state. Likewise with view all shifts, and then when we look at these others that are a little more involved, remember what we're not doing is pseudocode. We're not going to that level of detail. We're still at a very high level of abstraction, but not quite as high as just one little use case blob in the middle of the paper. For the activity diagram, plan shift, this is a description of the high level activities that will take place when that use case executes. We'll start off and create shift. Then, having created the shift, we'll add salesperson. Follow that down to the diamond shape, and that is basically a place for choosing things. So there's a guard condition here, more salespeople to add. If that's true, then we come back up and add salesperson again. So we've got a bit of iteration going on here. Decide, if there's more, add, if there's more, add, and so on. Eventually there will be no more to add, and then we drop through here and publish the shift, which means that the employees are now able to view the shift details. When it comes to modifying the shift, the activities are slightly different. Instead of creating the shift, we're going to open the shift, and then the task or the activity will be to view the salespeople on that shift. Now, since we're going to modify the shift, that means that we will either add a salesperson or delete a salesperson from that shift. And we can do that iteratively, adding and deleting as and when we want to. And eventually, once we've finished, and there's neither add nor delete that we want to do, then we drop out through the else and finish the activity. So the diagram that we're now looking at adds only a little bit more information, but it is going to be quite important information, as you see, because this will feed into our analysis model. And so the process has taken you from, let's talk about an activity as one statement, plan a shift, and let's put in a little bit more detail. Plan a shift means create the shift, add salesperson iteratively, and then finally publish shift. That's it. Nothing greatly detailed. And once you've done that for all the use cases for manager, you can then go on to all the use cases for salesperson and so on and so forth. Once you've got an activity diagram for every single use case, then you've finished the use case model, or at least for now, because sometimes you have to come back and modify it. So this is an iterative process. Don't forget, the USDP is iterative. So we might get into the analysis model a bit and think, oh, that use case isn't quite right. I have to go back and modify the activity diagram, or maybe I've got to go back and modify the use case model. So that's okay. You can keep going round and round the cycle, just keeping things in step and refining. So these two diagrams are pretty straightforward. Start a shift means open the shift and then record the start time. Similarly for end shift, and then for view my shifts, even simpler. So these activity diagrams might not be very complicated. Now that we've got the activity diagrams, we need to think about the analysis model. Now remember, on the analysis model we've got three kinds of analysis class. We've got interface classes that are shown like this. We have entity classes, which are basically used to store data in the system. And we've got control classes, whose job is to manipulate the entity classes in response to something from a boundary class. And so again, case by use case, we do an analysis model. Typically there will be two kinds of analysis model that we do. An analysis diagram. So we would, for example, if you just pop back to the activity diagram, we want to create a shift. Well, that says, well, that's data that I need to store. So I'm going to have a shift entity class in the analysis model. I'm going to add a salesperson. So there's going to be a salesperson entity class. And I'm going to perform this operation here, which is to publish a shift. And all of that's got to be controlled in some way. So there's going to be a control class. And for the actor, which in this case is the manager, to be able to trigger all of this, there's going to have to be a user interface, a boundary class. And so in the analysis model then we have the manager, who is associated with the manager UI boundary class. And that class will interact with two control classes, one for shifts, one for employee. Because when the manager wants to add a salesperson, then we've got to get that salesperson. So the manager UI will ask the employee handler, give me a salesperson with this name. And then the employee handler will get that for them. So these are some of the thoughts that might be going through your mind as you're developing the analysis model. And the shift handler will do likewise with a shift. And because we want to store for each person on that shift when they start and when they end the shift, then we're introducing this additional entity class called person shift that will have an association with a specific salesperson and will record the start and end time for that shift. And so those, as I say, are the thoughts that are going through your mind as you start to develop this. And then you think, right, well, let's build a communication diagram or a collaboration diagram, depending on which version of UML you're referring to. It's the same diagram, just two different names. And we've got essentially the same classes, except that this time we've got some additional information put on to the associations. Note that these associations are not showing any of the multiplicity or whether they're aggregations or compositions or anything like that, whether it's unidirectional or bidirectional. In the analysis model, that's not important. That's a lower level detail that we'll come to in the design. But at this stage, what we're interested in is taking these basic activities in the activity diagram and putting them onto the analysis model. So just flicking back to the activity diagram, we're going to create a shift. Now, a bit more detail is needed here because we don't just suddenly create a shift. And what we find is that the manager, the actor, asks via the manager UI class to create a shift. This UI class, number 2, will then ask the shift handler to create a shift. And the shift handler, number 3, will create a shift object. Then number 4, the manager UI class will ask the employee handler to find an employee. And the handler will then search through its collection of salesperson objects and get the one that matches the name that was passed in. And return now the salesperson. So the manager UI now has got a shift object and a salesperson object, and therefore number 6 can add the salesperson to the shift. which will cause the shift to create a person shift object, storing the salesperson in that shift object. So we're now building in a little bit of extra detail in terms of breaking down from the activity diagram these fairly high level activities and breaking them down into smaller activities that are related to the communication that's taking place between these analysis classes. And you do that for every single use case. Modifying the shift, there's the analysis class diagram showing the associations, and the communication diagram showing how they interact and the order in which these things are done. Of course, what you're going to find is that there will be a lot of repetition of these classes. So copy and paste is a very useful technique, and then just do a little bit of modification. Now, these activity diagrams, I couldn't build, sorry, not the activity diagrams, the analysis diagrams, you can't do in Visio, at least not that I've found, because they haven't got those symbols. So I've had to do this in Word and then produce the PDF of it. But don't forget that the analysis model is an interim stage, really, because once we've got the analysis model complete, we then move on to the design, and we kind of throw away the analysis model. We don't need to keep that up to date as the system progresses. What we keep up to date here on is the use case model, the design, and the code, and they keep those all in step with each other. So the repetition of classes here starts to say, oh right, this is giving me some ideas for what's going to be needed as classes in the design when I get to it. And as we work our way down through here, I'll just show you fairly quickly, you're going to see that there's a shift handler, a shift, a person shift, and a salesperson all the way through here, just different types of communication going on and in different orders. And then when we get to the analysis model for the salesperson, again, shift handler with shift and person shift and salesperson. So we're getting a really good idea from having developed the analysis model with these analysis classes, what classes we're going to need in the actual design. By the time you finish this, you've identified those classes. So we're going to have some kind of interface class. And in due course, that interface class, depending on what kind of interface we have, might be just a simple textual input-output via the command line kind of class, or it might be a much more complicated graphical user interface, in which case the analysis class will actually become in the design a lot more classes. You'll have frames, and you'll have panels, and you'll have buttons, and you'll have text fields, and you'll have all sorts of things. Now, for the purposes of this illustration, we're going command line. We'll keep it fairly simple. Now, having done all of this, we're ready to start the design. We've now got a much clearer idea of what is needed, the requirements, and the kinds of classes that we're going to need. So when we come into the design model, what we can do is from the analysis model, we can say, well, look, I'm going to need a shift and a salesperson and a person shift, and there's going to be some kind of association between them. So on the class diagram, we can show there's a salesperson and a person shift and a shift class. And now is the time to indicate what kind of associations we've got, whether they're just plain associations, bidirectional or unidirectional, whether they're aggregation or composition. And we can start to put that in. What we can also do from the analysis model, in the collaboration diagram, we start to get a really good idea of the kind of methods that are needed. For example, we have here, number 4 says log person shift start time. Well, that's something that is going to be done in the shift. And so we'll provide a method in the shift that's called log person shift start time. So we can use those annotations on the analysis model as a very strong indicator for what these methods need to look like. So if I zoom out again, we can see that what it turns out to be is there's the UI for the manager, the user interface class for the manager and for the salesperson. They're both using a shift handler. Manager UI is also using an employee handler, The shift handler interacts with shifts, and there's an aggregation of those, a collection. I'll just zoom in a bit on there. Note the open diamond, whereas the shift, if I zoom move across here, has got a composition of person shift. Remember, the difference between aggregation and composition is that with composition there is a coincidental lifetime. In other words, when the shift dies, so do the person shift objects that are associated with it. And the shift object is responsible for creating the person shift object, which actually will be in response to the method being called to say add salesperson. So the salesperson comes in as a parameter, and the shift object will create a person shift object passing in the salesperson. So we're now starting to put in a lot more low-level detail that is going to map directly into the code. And the way that we've got there is through this process that the unified software development process leads us in. And that pretty well sums up the approach to this. Perhaps the last thing to point out to you is that you're still going to have a main method, so you're going to have this little application class. If you're going for a command line interface, then all the input and output will be done in the main method, and you'll pass the details that are needed as parameters to the various methods that you call in the user interface class. Now, the great thing about this is that we've now separated concerns. This is a very strong software engineering concept, the separation of concerns. What we have from shift handler through to shift, person shift and salesperson, and from employee handler to salesperson, what we've got are business classes. These are the classes that whatever the interface looks like will always look like this. And what we've now got is a decoupling of the interface from the business, which means then that when the manager interface changes from being a command line interface to being a graphical user interface, all we've got to do is to unplug this class, plug in a graphical user interface package, and all that package then has to do is to make use of these existing classes. We don't have to change anything beyond there because of the separation of concerns. So in shift handler there's no input or output because that's an interface operation. All the interface operations go in the interfaces, and so the interface consists of the main method and these bits here. So you might find that there are some inputs and outputs in this interface because that is a text command line interface, so it's okay to do input and output there in those methods, but it's not okay to do input and output in non-interface classes. And you will be led directly by the analysis model, because you will have identified what are your boundary classes, in other words your interface classes, and you will have identified what are your control and entity classes, which are your business classes. So there should be no input or output from any of those. Only the boundary classes are doing input and output. And by the time you've gone through that process, what you will end up with is a consistent design that is going to be very useful for building the code. And essentially you could, if you had the tools to do it, auto-generate that and end up with at least the skeleton of your classes. So for example, let's pick on employee handler. How will this turn out? Well, we declare the class employee handler. We declare one array or some other collection of salespersons called sales team, and we provide two methods: find employee by name with an input parameter and returning a salesperson, and find employee by ID, again with one parameter on input, and it returns a salesperson. Of course, there's not enough detail there to build the system. You will also need to put pseudocode for each of those methods. And that's the only similarity really with what we were doing before Christmas. By the time you come to submit your assignment, if you've gone through this process, you will end up with a design that is very strong. It will be consistent with your use case model, and it will be consistent with the code, and you will have a whole load of pseudocode to describe these various methods that are listed here. And again, I was able to do the design model using Visio, and that comes out very well. Good luck with your assignment.